All right, let's dive into a really fascinating biological mystery. It's a story all about a case of mistaken identity, one where the body's very own defense team, well, it kind of goes rogue. We're going to look at why this happens and how a natural compound from green tea called EGCG is giving scientists some really interesting clues on how to crack the code.
So just imagine for a second, your body has this elite security force, super highly trained. Its one and only job is to protect you. But what if one day it gets some bad intel, a wrong memo? What happens when it mistakes one of your most valuable assets for a dangerous intruder and just launches a full-blown attack? Well, that, in a nutshell, is the mystery we're talking about today.
And here's the thing you gotta understand. This isn't really a problem with your hair. Nope, it's an inside job. It's a communication breakdown deep inside your body's security headquarters, the immune system. A classic and unfortunate case of friendly fire.
So what's really happening here is that the body's own security guards start seeing healthy, perfectly fine hair follicles as the enemy. The billion-dollar question, of course, is why? What wires are getting crossed to make them turn on their own team?
Okay, so to really get what's going on, we gotta meet the players, right? Think of it like a spy movie. You've got your dispatchers in the control room, you've got the big red emergency alarms, the guards out on patrol, and all their high-tech gadgets. So let's meet the crew. So first on our list are the chemokines. Now think of them like the dispatchers. They're the ones in the command center sending out signals and messages, telling the security guards, our immune cells, where to go and where the trouble is.
Now, among these dispatchers, there's one in particular called CXCL10. And this guy, well, he's a little extra. He's not subtle. When he sends a signal, it's not a quiet memo. It's like he's smashing the giant red emergency alarm button that sends every single guard sprinting to that one location.
And who comes running when that alarm gets smashed? That would be the NK cells, which stands for natural killer cells. Yeah, intense name, right? These are your security guards, the boots on the ground. When that alarm goes off, they are the first responders and they show up ready to take down any threat they find.
Okay, so how do these guards know who the bad guys are? Well, they've got some pretty slick gear. On their surface, they have these things called NKG2D receptors. Just think of them as high-tech threat scanners. They're constantly scanning other cells, looking for any sign of stress or danger. So you've got dispatch, you've got the dramatic emergency alarm, the guards and their fancy scanners. Sounds like a pretty solid system, doesn't it? Yeah. Well, in alopecia areata, this is exactly where things go off the rails. Let's see how it all falls apart. Okay, so this is basically the play-by-play of the whole screw-up. It starts when, for some reason, the hair follicles send out a tiny little stress signal, but our over-the-top dispatcher, CXCL10, sees it and just slams the alarm button. The NK guards swarm the area, their scanners are on the highest alert, and they completely misread the situation. They see this stressed out but totally harmless hair follicle as a major threat, and they attack.
But hold on, because this is where the plot thickens. What if you could send in some kind of negotiator, someone to calm everyone down? That's exactly where researchers started looking at this compound from green tea, EGCG. Now, it is not a cure, but it might just be a really important clue. So what is this ECGC? Well, it's basically the superstar antioxidant in green tea, the thing that makes it so healthy. And the reason scientists are so fascinated by it is that very, very early research in the lab suggests it might be a pretty good negotiator. It seems to have a way of talking to the immune system, maybe even convincing it to just, chill out a bit. So the question is, how would a negotiator like ECGC even start to de-escalate this whole mess? Well, researchers are looking at a couple of key ways it might be able to get this super hyped up security team to just take a deep breath and stand down. And this slide just lays it out perfectly. On the left, you've got the system on high alert. The CXL10 alarms are blaring, there's all this inflammatory chatter, and the guards are agitated, ready to fight anything. And on the right, well, that's the goal, a much calmer system. The alarms are quieter, and the guards are way less reactive. The big question researchers are asking is, can EGCG help flip that switch? So here's the game plan, based on what scientists are seeing in the lab. First, EGCG might be able to just walk over to that loud CXL10 alarm and turn the volume way down. Second, it could help quiet all of the other pro-inflammatory chatter. You can think of it as telling all the guards to stop shouting and hyping each other up. And finally, it might be able to interrupt the main signal pathway that's basically stuck on the attack command. Okay, this all sounds amazing, right? But this is where we need to pump the brakes, hard. And this is, without a doubt, the most important point of this entire explainer. We absolutely have to be responsible with this information.
So let's be absolutely 100% crystal clear on this. Everything we have talked about is based on early preclinical lab-based research. EGCG is not an approved treatment, it's not a cure, it is a fascinating clue in a huge scientific puzzle, not a prescription for a medical condition.
And that brings us to the #1 rule of, well, of everything. Please, please, please never, ever make changes to your diet or start taking new supplements because of something you see online. The only person qualified to give you health advice is a healthcare professional who knows you and your specific situation. End of story.
So after all that, after meeting the security team, seeing the false alarm go off, and looking at how a potential negotiator might work, what's the big idea we should really walk away with?
Look, the real story here isn't actually about green tea. It's about something way, way bigger and more exciting. It's the idea that we are just starting to learn how to communicate with our own immune systems. We're figuring out how to gently recalibrate the whole system, not just shut it down. This is the absolute frontier of medical research, and we are in the very earliest days of exploring it.
And that kind of leaves you with this one last huge question, doesn't it? If we can truly crack this code, if we can learn the language to safely and gently de-escalate a false alarm in our own bodies, what other mysteries, what other cases of mistaken identity could we one day understand and maybe even solve? Now that is a future worth getting excited about.